Hello, for those who missed class who need some extra help on this lab, let's go over it. So we had an eraser on the whiteboard, flat first. In that case, you only had two forces, gravity and normal, and they were equal to each other because the object was at rest. An object at rest stays at rest, an object in motion stays in motion with a constant velocity. That's Newton's first law. So that tells us that the two forces, normal and gravity, are the same. So gravity, normal. We measured the mass of that little eraser, and it was only 5.3 grams. When we find gravity, we have to have the mass in kilograms. So we divide grams by 1,000 to get kilograms, which gets us to 0.0053. That's kilograms. Then when we multiplied by 9.8, that got us to 0.052 newtons, which was force of gravity, which was equal to normal force on the flat surface with no other forces interfering in the vertical direction. And that was all fine. Then calculations are right here. You measured the length of the board. I'll just say mine was 16. Then you had an experiment. You had 5 trials to figure out lifting one end of the board and measuring the height to which you could lift it before the eraser started sliding down. Just for the sake of the exercise, I'm going to say it's, 8 centimeters on average. So then when you draw the incline, you know the hypotenuse, which is 16, and you know that this is 8. Then sine of that theta, which is right here, is the ratio of 8 to 16, which 0.5. That's just my example, all right? And that means that the angle is 30 degrees sharp. Y'all had your own. Now, draw the FBD for the eraser while it is resting on the inclined board. So at my 30-degree incline, there you go. Then you have your gravity straight down, which now has 2 components. Horizontal is taken care of by friction. Vertical is taken care of by normal force. So force normal, normal, friction static, mg. So at the moment right before it starts sliding, net force equals 0. That is due to Newton's first law. An object at rest. I don't need you to write the entire first law. The eraser was at rest. Boom. That's enough. Then state the relationship between the forces. So I know that this being mgx and that being mgy brings us to the realization that force of friction static was equal to mgx, which is mg sine of theta, while normal was equal to mgy, which was mg cosine of theta. Then calculate the forces. So for me, it's going to be 0.052 sine of 30 degrees. That will be the force of friction static. And then 0.052 times cosine of 30 degrees would be force normal. Now, I asked you to round it to the nearest degree right before the eraser started sliding, because I'm just making up examples. Let's say that this, when I calculated it, let's say this was maybe like 6.1, then that would be probably 13.3 or something like that. Again, I'm just making up my numbers. That would give me the exact 30 degrees. So whatever you had here with decimals, drop the decimals, use that. And if you overrounded, drop down. So for example, if you had like 25.7, go down to 25. Determine μs between the eraser and the whiteboard. You remember that force of friction equals mu times normal force. If we specifically go of static friction, then it's that formula. All we did was change the subscripts. Then mu s is the ratio of friction static divided by normal there. You end up with mg sine of theta divided by mg cosine of theta, which ultimately gets you to the tangent. For me, it was 30 degrees. So if you actually find the tangent of your critical angle, that is the value of mu s. And that's how you solve it.